Hello everybody. So welcome back to the conference. I mean, now we are in our third edition of the Space Intersects Internet. So the topic of the discussion is the role of the non-geostationary orbit satellites in the evolved internet. As you know already, so it's the third time we have this type of conferences. We are trying to come up with different issues that are happening on the ecosystem of the non-geostationary orbit satellites. It's quite challenging. There is a big momentum on that, and we want to be sure that we put together key people. Actually, we have a very good set of C-level speakers today, and the idea is to open up what are the discussions, what is the situation, and so on. So just for starting, I want to share with you some of the figures that we have today in our session. Let me share a second. Okay. Good. So here in this picture, I wanted just to show you what is the presence today in the audience that we have. It's quite interesting to see how different parts of the world have interest on these topics, and at least some people over there wants to listen our speakers. So just to give you an overview, we have more than 150 people registered on this activity today in this conference. Then also I wanted to, all of you have done just a small questionnaire when registering, but it is quite interesting also to see what's the level of the audience. I mean, what type of audience do we have today, right? Although we know that there is much more researchers than maybe low films globally, but the interesting thing is that we are covering the whole value that we wanted for this conference, because we are going from the business side to the technical part, and we are covering the whole overview of what this technology could mean. So it's a good representation of the sector. Then here we have, I want to thank the participation of our guests today, which will bring the attention and will come out with the challenges that they have. So it's an excellent panel. And I will now briefly go to the presentation of who are the speakers, but just to give you an idea about what is the planning we have today, to give an overview. I will not enter into detail, but just to reinforce what are the two sessions. Then I also want to thank the government of Catalonia, the Mobile World Capital, and the Chamber of Commerce of Barcelona for the support that they have done on putting it together and to streaming it all to you. So after myself, we'll have Riyad Hartani, which is the co-organizer of this conference. He will give you an introduction about the LEO ecosystem. Then we will have the first panel, which is moderated by Frank Ryle from China Partners. And here we have the CTO and co-founder of Link, which is Tyke Spiegel. We have Rob Spirit, which is a change of last minute change. Is the CEO of Lacuna Space. Mina Mitri, CEO of Kepler Communications, and Stephen Anjoer, which is a 5G venture lead from Thales Alenia Space, which I'm pretty sure that will come up with very interesting and strategic issues in the discussion. Then in the second panel that we have today, which is going to be moderated by Mrs. Monica Roca, it's going to happen at 5 p.m. Central European Time. She's the president of the Barcelona Chamber of Commerce and also an entrepreneur into the space sector. And in this session, we'll have Jordi Borrera, which is the VP of Technology of Open Cosmos, Jaume Sampere, the CEO of Satellite. We have Daniel Marco, which is the General Director of Innovation and Digital Economy of the Catalan government, Thomas Jensen, Senior Vice President of Satellite Communications of Gatehouse, Satcom, and Paul Febre, which is the CTO of Satellite Applications and Catapult. So after all, I think that we have a good panelist. Hope you enjoy, and I hand over to Riyad Hartani. Thank you. You're mute, Riyad.
Thank you very much, Sergi, and welcome to all. Good morning, good afternoon, good evening, wherever you are. We see participation from different parts of the globe here. So so would like to welcome you to this third workshop on the NGSOs, which includes LEOs and MEO like constellations. For those who joined the first couple of workshops, And if you recall, the first one was primarily focused on state-of-the-art, the technologies behind these type of constellations and the business models behind, but fairly broad, right? The second one was very much focused on the synergies between telecom operators, mobile operators, and these new constellations, with quite a bit of emphasis on the large broadband constellations and the impact those are having on the overall dynamics. In this one today, we're going to approach these topics as well through the two panels, but specifically, have a focus on what we call a direct satellite to device service, which is sort of like constellations where the devices will be talking directly to satellites. And I think there's a lot of innovation, a lot of work going on in that space. So focusing on that will be one of the things we're going to be doing here. We put this slide showing some of the LEO, MEO constellations that are being built, launched, and deployed at the moment. This is not exhaustive. This is just like a snapshot of where things are. But one thing to take out from this is there is clearly a lot of innovation going on in this space. There is a lot of investment going on in this space as well. And I think like it's a very interesting time to sort of explore what's happening both from a technology side and from a business side, right? And that's going to be like the focus of our discussions today. If you look at what we call direct satellite to device, there are multiple ways of categorizing them, multiple dimensions as well. I think we're listing two here. One is in terms of like applications that these constellations are focused on. So you will see application in the remote offshore personal connectivity direct to end users. You will see like focused on different types of IoT connectivity, as well as aspects that relate to critical communication and obviously government applications, right? So that's one way to look at them from application perspective. Another way to look at them is also in terms of the type of spectrum that they're leveraging or using. Mobile spectrum to either licensed mobile or unlicensed or satellite spectrum, right? So we'll see all these combinations. So overall, there is a lot of promise with a lot of risk attached to it as well. Different numbers have been put together in terms of addressable markets. A reference here, and a SAR reference as an example, talking about a 35 billion service revenue in 2030, right? So these are pretty large numbers, so the opportunity is there. The question how to get to it and what are the challenges to overcome both on the technology side and on the business side to get to that, right? Typically a lot of it will be business case drivers, and I think there is a panel just on that. Just like, we put an example here that applies mostly to broadband constellation at scale, not really for this direct satellite device. And you see a split between the cost, to build the satellites, the ground station, the launch, and anything like, in terms of devices, right? Some of them are predictable, others less predictable. So there's this whole cost equation, CapEx, OpEx over time. There is obviously the revenue equation is equally important, and the panelists will definitely look at that from the different perspectives as well. Opportunities there, but as we know and as we've seen in the past as well, challenges are there too. We're listing a few of them here, like things like long lead times to go and deploy and sell the service, the trade-offs that one has to do in terms of end user terminal costs, the quality of service, the penetration, the pricing. Basically, it's all about trade-offs here. So exactly how to go after this deployment is really about figuring out the best trade-offs, right? And there are more broader challenges that are popping up in terms of space debris, space collisions, all of these aspects that are definitely things of concern, right? And last but not least, I would like probably to highlight all the funding requirements and how to replenish this funding as like these constellations have to be renewed and evolve and so on, right? So a number of business challenges, and I'm sure the two panels will shed lights on a lot of this today. Then one thing that we're going to be addressing specifically in these panels is really the developing trends that are evolving at the moment. There are a few, just listing some of them as far as what we think is very relevant. There is this whole dimension of integrating all these satellite constellations with what's happening in 5G and beyond 5G through 3GPP standardization, through different ways of coordinating spectrum and having all the licensing rights and developing all the reference architecture. There's a lot of work going on there, and I think there's a lot of promise in terms of figuring out how to leverage the 5G ecosystem to make the economics of device to satellite communication more viable and more economical. So that's one. There's another dimension, which is basically integrating the whole constellation into end-to-end internet value chain, which include all the cloud and application hosting. So this whole notion of basically seeing the constellation as a complement to all the the clouds and edge clouds, and you see partnerships going on between the constellation themselves and the cloud operators to basically optimize delivery, leveraging edge cloud over this type of constellations, right? Other things as well that are happening that are probably in adjacent markets, but very much in the context of leveraging these constellations. Example would be this quantum key distribution, anything quantum security, leveraging the satellite constellation to have reach in terms of key management, key distribution, among other things, right? So yeah, a number of developing trends. I'm listed 3 that I believe are very important here, but there are others, and I'm sure the panelists will be addressing them as we evolve. So as a bottom line here, really, as we get into this next generation of constellations in the LEO and MEO orbits, what is the key theme here is really the notion of integrating these satellite constellations in the end-to-end internet value chain, which have multiple components, right? I mean, some are listed here, basically how they would work with, or what are the application in private enterprise networking, right? What are the applications in terms of deploying alternative model for fixed wireless access, how they would complement the cloud CDNs or the submarine networks, how they will complement the geo constellations that are also evolving and state of the art is progressing quite nicely there as well. So I think the theme in this workshop is really to put these innovations in the NGSO space at the center of what's going to be happening over the next few years, and really seeing how this integrates with everything else in the internet, overall, and how this complementarity, can lead to new business models, service models with benefits to the overall ecosystem. So I will stop here. I think was just a way to give you a snapshot of the topics we're going to be discussing, and I will hand it over to Frank to run the first panel from here. Thank you.
All right. Thank you, Riyad. Thank you. Thanks, Riyad, and thanks, Sergi, for this introduction and for setting up the context for this workshop. So I welcome everybody to the first panel. We will be diving deeper into this direct satellite to device sector. And we have with us 4 panelists coming from different companies in that sector. I would like to introduce them first very briefly. We have Taigi Spiedel from Link. Hello, Taigi. We have Mina Mitri with Kepler and Stefan Anjouer with Thales Alenia Space. And we also have Maria Kalama with Lacuna. So we were between Maria and Rob. Rob unfortunately had some technical difficulties, and Maria is back online with us. So welcome, Maria. I want to make sure that all of you have your mics and cameras ready. What I would like to do is to basically set it off with a few questions to you, and then we can take some questions from the audience as they will come in the latter part of this panel. To start, maybe Taigi, what I would like to do is to start with you, and then for every one of you is to take about a minute and tell us specifically what your company is doing and the type of innovations that you're bringing into this satellite to device market space. You are all addressing it from different perspectives, so we're very curious to see how you're handling and what your perspective is on this market. So Taigi, I would like to start with you, if you don't mind, to kick it off by giving us an overview about Link.
Sure, Frank. Yeah, thanks. Yeah, so my name's Ty Spidell. I'm the Chief Technology Officer and co-founder here at Link. We are building a constellation of satellites in low Earth orbit that are dedicated for mobile broadband connectivity, satellite direct to handset or IoT device. About, let's see, a little over half a decade ago, I actually invented a method for taking a satellite or taking a base station and putting it on a satellite and modifying it in a way that allows it to connect to a handset without any modification to the handset, hardware or software. And so our constellation is intended to work for any 5G, 4G, 2G device, existing or not yet existing, all around the planet, for global, connectivity, filling in all the gaps. Thanks, Frank.
All right, thank you. Next, maybe Mina, you would like to talk a little bit about Kepler and your new solution that you have launched?
Hey everyone, thanks so much for having me on the panel. My name's Mina, I'm the co-founder and CEO of Kepler Communications. Kepler as a business exists to bring internet access outside of Earth. So it's really a great topic to have here on sort of what is the extension of the internet and what are we planning to do. And what that means for us is providing real-time, always-on communications as soon as you step outside the surface of the Earth for everything like rockets, space habitats, Earth observation satellites. We recently announced our Ether product, which is the equivalent of a SIM card that you can attach to your satellite and get always-on real-time communications. So I'm super excited to spend some time talking with the panelists here and explore some of the research topics that we think are most interesting to us as we go down this endeavor.
All right, thanks. Will be very interesting to see how that backbone will fit into all that stuff related to back to Earth. So Maria, maybe to start with you and with your IoT service and satellite constellation, would you like to go ahead?
Yes, sure. Hi, Frank. Hi, everyone. So I am Maria Calamán, and I am the Director for Business Development at Lacuna Space. So you've kind of given away what we do, Frank. So it is true. So we are fine. So we are developing a constellation of Internet of Things satellites using the LoRaWAN protocol. Okay, and so we have already launched 5. So the service has been tested and is operational, and we're moving ahead with partnerships. And we also plan to start launching a lot more in batches in the next year. So that's us, but I'll tell you a lot more about us and show you some stuff later on.
All right, great, thanks, welcome. And Stefan, you're coming from another aspect. So maybe you can tell us about Thales and the work you're doing, and specifically about the activities you're engaged in related to 5G.
Yes, thank you, Frank, and I'm very pleased to be with you today for this panel. I thank you for that. So my name is Stéphane Angerer, and I am basically the 5G venture lead in Thales Alenia Space, meaning that I am in charge of the 5G activities for the company. What is interesting is that Thales Alenia Space is involved in this 5G and non-terrestrial network activity since now several years at the 3GPP and standardization level. So the company has started this activity somewhere by 2017, and we continue to push because we believe this is a great step forward for the integration between the non-terrestrial network and the cellular network, and an opportunity for the space industry to benefit the 5G standard moving forward for the introduction of new services and to address new markets. So the Thales space, as I did explain, continues to drive this activity with the support of the European Space Agency, strong support. And in parallel of that, of course, given the heritage we have with LEO Constellation as a satellite manufacturer, we also prepare the future with specific design of the next generation of the satellite to address and provide this level of services that 5G will enable.
Great, excellent. So what I would like to do is basically to have certain questions to each one of you, because you are coming from different segments. And starting with Taigi, the key question here is many people say, how can you connect a mobile handset that's designed to connect to a cell site that's 500 meters away with a satellite that's 500 kilometers away? So can you just tell us about what kind of design issues you're dealing with and how do you make that connection to a satellite?
Sure. Yeah. So we spent a few years very early on, certainly pitching investors and mobile network operators and technologists around the world about how this could be done. And there was a lot of skepticism. We've actually proven it. So while we have the patents, we've also launched 5 satellites and proven this, getting a satellite to connect to a handset without any modification two-way connectivity. The way that you do it is it's really just physics. You can take a satellite of even a relatively modest size with an antenna that's with modest directivity, point it down at the Earth, and if you're operating in pretty low Earth orbit, you can close the link to the handset using, in particular, we're focused on the UHF band in the cellular world. So frequencies below below a gig, so 617 to 960 megahertz. So that's kind of the key. Once you figure out how to close the link budget, you have to solve for 2 things. The protocols are designed fundamentally to, the 3GPP had terrestrial towers and terrestrial handsets in mind when they made the standards, right? So if you're any further away than about like 35 kilometers in GSM, LTE, you can configure the PRATCH to about 100 kilometers. But typically, no longer than line of sight for a terrestrial tower, then it won't work. And if you're moving any faster than like a bullet train, it usually won't work. And so obviously you put a base station on orbit, both of those things are broken, and you have to solve for them. And that's what we've specified in all of our patented work, how to solve for the Doppler shift, the propagation delay, and then closing the link budget. One analogy I like to use is if you think about the terrestrial network, when you're in an elevator, you want to still have cell coverage, right? And when you're going horizontal with these links, it's no longer, path loss is no longer 1 over r squared. It's 1 over r to the, sometimes as high as 3 or even 4, particularly in urban environments, and they have to penetrate buildings and all this good stuff. And the mod cods are really good to allow you to click into different data rates depending on what your signal energy is. So there's a ton of margin in the terrestrial networks kind of built in naturally because of, the world we live in and all the urban canyons and whatnot, and trees and forests. And so if you're just going straight up with that signal, it's more of a Ricean channel, so fading isn't as bad, and all of that extra margin you can just bake into the additional path loss that you get going 500 kilometers instead of 500 meters.
So I wanted to ask you, because you mentioned satellites of modest size. What type of size are we talking about here?
So we fly satellites that are, they're microsatellites, and this is all public in our filings with the FCC for our commercial application. The satellite I have on orbit right now is 1 meter by 1 meter in form factor and very thin, about 10 centimeters thick. We filed with the FCC for our initial fleet of satellites to grow up to only about 1.5 by 1.5 meters in surface area, small enough to fit on an ESPA port, and microsatellite size in terms of mass.
Okay, interesting. Maybe I would like to move on to Stefan, because in a way you're working complementary. You're doing a lot of work at the 3GPP, and in terms of integrating on the backside of the network. So what Taigi has addressed a lot of the stuff that happens on the physical layer. Can you maybe, Stefan, explain how important that work that is going on at 3GPP, and specifically and maybe that's a question other people can comment on. We're focusing on 5G. Is that really what's needed to connect the unconnected, or do we go with a 2G or 3G technology, right?
Yes, first, maybe to answer your question, Thales Alenia Space has been, I would say, deeply involved in this 3GPP process because we believe there is a global standard that could make this integration between both the satellite and the terrestrial networks. That's the first opportunity we have to make this integration, and because we believe there is a benefit on both sides, meaning on the satellite stakeholders side and as well for the benefit of the mobile stakeholders. Typically, if we start with the mobile stakeholders, this is an opportunity for them to extend the 5G unserved areas and to provide a kind of what we used to name true anytime, anywhere, any device type of coverage, either with direct access or even with indirect connectivity through the satellite solution. And also to reinforce, which is something also critical, the network resiliency that are deployed on the ground. That's what we believe is, I would say, the main interest and benefit for the mobile stakeholders. And now, from a SATCOM perspective, it's an opportunity as well to address the needs of the end users in terms of combination of mobile and satellite access, and typically through mobility or multi-connectivity, and also to have multi-vendor systems, meaning combining network infrastructure and terminals, and benefit the overall cost reduction by leveraging the 3GPP economy of scales in these markets. And of course, last but not least, this integration within the 5G standard would be an opportunity and a benefit for the SATCOM to natively support all 5G features coming, like energy saving, mobility, application and service platform, and also some capabilities through the slicing with a better integration between the satellite access network and the cellular radio access network. So that's basically what we think is the highest level of benefit for both sides. Now, to answer your second questions, is it the right way to address, let's say, the needs of the final users? That's a matter of integration. Of course, with 2G, 3G, and 4G, we can do things, but maybe with less level integration. And 5G will come with higher and broader number of applications that could really benefit the both industry, meaning SATCOM and the telco, traditional telco.
All right. Maybe we can come back to that later, because there are interesting dynamics happening between telecom and SATCOM spaces. But I'd like to ask Maria more. You're working on the IoT side, and one of the big questions on the IoT is related to the markets. Where are you selling? What type of services are you selling? I'm completely switching gears here, because I think on the IoT side, that's always been one major question. So I'd like to get that out of the way, and maybe have your take on, you can share with us what you're doing on that side.
Yes, sure. I think one of the first questions that that people have is, what is the Internet of Things? Yeah. And I think especially, where it is that we play is in markets such as agriculture. So smart agriculture, people want to measure soil moisture on the ground. We do quite a lot in tracking. And obviously tracking is a great application for satellites and also for our system, because the kinds of devices that, we enable are really, really small. So this is a prototype. So you can see it's really small, really light, low cost. And I'll come back to why it is low cost. Yeah. Low cost does not mean low quality. Fits in the palm of your hand. So tracking is a great application for us, obviously. Also because, again, our system offers seamless integration with ground systems, with ground LoRaWAN systems, okay? So if we have a device, it's in a port somewhere, it can use the LoRa ground network, and then it can pass over the satellite for the rest of the journey. So again, that's another great enabler of LoRaWAN, because it enables roaming between satellite and the ground solutions. And of course, we also do all the classical satellite and SCADA applications, but obviously at a much lower cost and in a new way. So oil and gas, energy, the energy sector, utilities, these are all the things that we serve, but again, at a totally new cost, and also using a standard, yeah? So I think using a standard is very important, because I think, as Stefan mentioned, all of a sudden, the end user has a huge range of devices to choose from, okay? So this is no longer a niche application for satellites. So we have a whole ecosystem of thousands of device makers that are making devices, that are making LoRa-based devices that are very simple to upgrade to satellites, okay? So in a way, I think I've probably answered two questions there for you, Frank, which is, what are the applications, what are the markets, and why would they buy from us in these particular markets and applications?
Mm-hmm. And how close are you integrated with the land terrestrial systems? How does it work in terms of like other business and
yeah. So there's a few. So technically, how does it work? And technically, the way it works is very simple. And again, I can show you. So what we do is we use standard chips and standard transceivers. Okay. And we also use the same frequency bands. So the only difference in hardware between a standard device, ground device, and a satellite device is the antenna. And the antenna can also work, of course, for the ground network. So technically, the way it is achieved at the device level is the device is virtually the same. And obviously, in the device firmware, you can choose whether and how you transmit either to the satellite network or to the ground network. And then the way this is achieved at the network, what we call the backend or the cloud, is basically, again, because we're using native LoRaWAN, we can actually roam packets, and we can support standard interfaces for roaming between our servers and other servers. I'm not quite sure if I pitched it too technically or not, but I think the simple answer is, because again, we are using the same protocol, the same interfaces, the same electronics, there is no question of integration. I mean, the technology is virtually the same, with obviously a few changes that I've mentioned.
Yeah, good, excellent. And Mina, you're basically having a different proposition now. You're talking about basically having the backbone for satellite connectivity in space. So maybe you can talk a little bit about ISLs and what you're doing actually, especially, how do you differentiate, and what's your go-to market, and where do you see that market heading? Yeah.
Yeah, for sure. So maybe to provide some background context here on the problem that we solve, it's actually, the most satellites today, when they're going into low Earth orbit, they have intermittent periods in which they're able to communicate with the ground. A lot of satellites today will fly North Pole to South Pole within 90 minutes, and then they have a 10-minute roughly contact period when they're over a land-based station, and they can downlink their information that they've collected through the course of the life of that orbital period. So today, there's very few services, if not any, that exist that allow people to connect in real time to an internet backbone when you're leaving outside of Earth. There's a few government services that are run by the US government and the European government, but those are only strictly accessible to remotely targeted government missions. Now, what's changed is we've seen this massive influx of users for space. So the number of net new users that are coming online to space has significantly changed, and building the commercial case for a entity to come and provide a similar service that allows them to have real-time communications. And the way to think about it is a mesh network operated outside in low Earth orbit that enables anybody within low Earth orbit, or near Earth orbit, I should say, to have real-time, always-on communication. So data gets routed to the closest node that's available to you, and then it bounces through the various nodes within the network, eventually downloading into an Earth-based station that's directly within view. And so this solves the problem of intermittent connectivity, and there's actually two halves to the equation that people are usually looking to solve. There's the first half where you want to track, command, and control your space asset. So, telling it to take a picture or telling it to go out and observe a certain location or to collect a sample from a particular geography. And that's one half of the problem. So if you imagine, operators are oftentimes waiting upwards of 90 minutes to solve for that first half of the problem. I want to command the space vehicle to go and take an action. There's the other half of the problem, which is how do I download all the data? So, I do my first loop, I get a command of what I'm supposed to do. I wait another 90-minute orbital period, and then I decide how to download this data and what data I'm going to download back to an Earth-based station. So the early services we're launching, in fact, have a lot of parallels to what work is taking place in IoT for the first half of the equation, the ability to task, command, and control space vehicles. It looks at similar protocols. And in fact, we look at and use physical layer protocols that were originally built for terrestrial-based communications. It looks at similar networking stack challenges. There's some few innovations that we have to think through when it comes to delay tolerant and disruption tolerant networking. There's a few innovations we have to think through around all of our network nodes are moving in space and time. So those are challenges that are not common to the entire terrestrial networking ecosystem. And as we work through those challenges, we actually start to build up and create an internet infrastructure outside of Earth. And that's historically not existed. But what we've seen here on Earth is that internet infrastructure helps to build whole digital economies. And so as we see more activity taking place in space and more users taking advantage of space, the buildup of a digital infrastructure or an infrastructure that allows for true internet access outside of Earth will replicate some of the digital innovations and economies that we've seen built here on Earth. So we're pretty excited to be launching that. We've got a few trials that are launching into orbit at the end of this year, early next. So I think is a January net launch date where we'll have another 4 satellites that are going up doing our satellite-to-satellite relay communications. We've got a few announcements we've made with the European Space Agency as some of our early customers signing on to use the service in its intended form. And we'll have a few more announcements that are coming out. But I think this type of innovation takes advantages of a lot of the things that have been developed here on Earth, the networking protocols and the core technical expertise, and extends them to an area and application that they've not traditionally been used for. And
what type of bit rates we're talking about for that service?
Yeah, so there's 2 distinct service offerings. In tracking, telemetry, and control, we're offering bit rates anywhere between 10 to 40 kilobits per second, always on. And that tends to be substantial for most tracking, telemetry, and control applications. And in the latter half, which is the data rate to move large volumes of data off of a space vehicle, we're offering 10 megabits per second on the low end and upwards of a gigabit per second. So really like a fiber link in the sky. And in fact, actually takes advantages of optical communications technology for the later half of the service and RF technology for the earlier half of the service.
Okay, so I'd like to take one question from the audience that we have received. So basically question from Halim Yanikomeroglu. Hello, Halim. He's asking basically direct access to user terminal with cellular air interface such as 5G. Currently, the ITU spectrum policies do not allow this. So any comments on that? How do we get the spectrum issues resolved here?
If I may, this is true. There is activities at ITU level that should circle back with the 3GPP activities. But in the release 17 of the standard of the 3GPP, today we consider to rely on the mobile satellite spectrum that guarantees to limit especially the level of interference with the terrestrial systems. Of course, there is other solutions that could be considered, especially also the use of the terrestrial spectrum. But that opens to other technical challenges to avoid disturbing the cellular coverage. But that's true, and there is some activities that are happening these days to make sure that there is a specific regulation that will enable the service to be deployed.
Okay. And Taiga, I don't know if you have anything to add to that because you've been involved in this.
Sure. Yeah, I think so. So, the ITU is fundamentally a coordinating function, right? They're not really a regulator. So our approach has been to partner with mobile network operators directly who already have bought, oftentimes via auction, licenses to this spectrum, and they own it and they use it for their services. So by partnering with them directly, and we've discussed this approach with regulators in various countries around the planet already, and they're very warm to it. From their perspective, this mobile network operator owns this license to this spectrum, and they provide this mobile service. Link, and they come, we go hand in hand to the regulator with them, and they say, hey, we want to use Link. They're putting cell towers on orbit, and we want to extend our coverage to everywhere. And there's a lot of public good and benefit that comes from that. And regulators have taken the position that, if we're working together and coordinating things like interference, and we're providing a meaningful service for the general public, that the regulator in country has been very, very supportive of that. And so, I suspect, as long as partnerships are put together correctly, and the utilization of spectrum is done with the really the authority of the MNO who has the license, then those problems can be surmounted, as we've done.
And Maria, I don't know if you wanted to comment, because you're on the unlicensed side, but I think it's similar. You basically, it's not really an issue, right? You basically can deal with the regulators independently, I think.
Yes. So of course we do have an ITU filing. Yeah. So that is done. But I think for us, it is, as you say, it is very different, because we use the unlicensed bands. And we observe the same regulations as to power limits and what's called the duty cycle as a ground LoRaWAN networks. Yeah. So therefore, there isn't an issue there. So there are, of course, certain national jurisdictions, that we may have approached, because they may have specific specific conditions as to the use of satellites, but so far we have had no issue whatsoever, because once again, we observe exactly the same regulations and comply to the same regulations as what is known as SRD devices, or simpler for the audience, ground LoRaWAN networks.
I'd like to ask a question that's maybe common to almost all of you. And that's about, how do you see, in terms of like the future going forward, in terms of these IoT technologies that are happening on the 3GPP side, and that are happening also on the LoRa and the other standards? How do you see that is evolving? Because there was, in the last few years, a certain kind of competition, right? And now what we see is the market has settled largely on the LoRa for the unlicensed band, and for the LTE-M and NB-IoT, depending on geography, for the 3GPP. So carrying that forward, how do you see, like, any thoughts on how this market could evolve? It's a bit of an open-ended question.
Maybe I'll provide a quick comment here. I think one of the things we're quickly seeing is a convergence between satellite and terrestrial applications. And while we've settled on these two standards, both of them are respectively trying to identify their own mechanisms to support outside of Earth or NGSO operations. And I think we've seen that in participation with the 3GPP release 17. Stefan had mentioned this a bunch, and that general convergence we're seeing across the two platforms that were historically divergent. Space and space vehicles would build their own custom protocol, custom hardware, and it would be their own physical layer and exclusive use of that to communicate with their networks. But what we're seeing quite a bit in what both of these respective protocols, not just the narrowband IoT and LTE Cat-M work, but also even LoRa is converging towards a solution where they both are able to respectively support a convergence between satellite and terrestrial. I think the goal there is just, for these things to work, we need mass amounts of coverage, and the only way we accomplish that is through a converged protocol.
Okay.
Yes, I fully agree with Mina. And there is a lot of activities in the sense of a convergence, especially at the 3GPP level. And the best demonstration is that there is a specific work item which is discussed at the time being in the release 17. So this is progressing the right direction with a true integration, especially for narrowband IoT, EMTC, for the license spectrum, and later on RedCap. I believe that the next step would be RedCap. So there is definitively a common willingness to move this direction.
Yeah, here. I agree with Mina and Stefan. Well said.
Taigi, I'd like to stick with you for the next question from the audience. Basically, they're asking what kind of speeds and overall capacity that you can support.
Yeah, okay. Well, it's kind of a loaded question. So the way that we do this, right, we design a satellite that has a certain amount of capacity, a certain number of beams that we can put out. The amount of capacity that we can serve in terms of service link is really driven by our agreements with our MNO partners. So they're going to specify like, hey, look, I want you to put a beam down in this area and provide cell coverage there and use this, 5 megahertz or 10 megahertz and use LTE, right? Or some, think about Africa, right? 2G is still kind of king in a lot of parts of Africa. And so there's interest in putting cells down where, you're just using, either one or some number of 2G, 200 kilohertz carriers. So it's very much dependent on agreements with MNO partners. We can hit with a single satellite, even the one we've got on orbit now. We can support up to 20 megahertz of LTE and hit broadband speeds. But we would have to spread those broadband speeds over a relatively small number of devices with the current satellite. As we add more and more satellites, we'll be able to provide broadband speeds to a very large number of devices.
Right.
North of 10 megabits per second.
Good. And I have another question from the audience to Mina, basically to talk about the Everywhere IoT service. Can you just talk a little bit about that, Mina, and tell the audience what it is?
Yeah, for sure. So that was basically a capability building technology where we wanted to further develop the protocols and physical layer hardware that we'll be using on orbit for our Ether service. In Everywhere IoT, the intention behind it is pretty simple. It's automated message reporting. So the idea that someone can connect a device in a remote location and continuously report on its health and wellness. So for the purposes of that, we've kind of had a narrow demonstration and launched with a select set of customers to allow us to kind of test in real world settings what we would eventually deploy for our Ether service. But the priority for us remains on the Ether service.
Okay. I would like to maybe shift gears to basically talk about the innovations that each one of you is bringing in onto the market, right? Maybe that's already correlated to some of the stuff that we spoke about, but if you can, like, maybe I'll start with you, Taigi, because you talked a lot about the patents, and we understand a lot of the innovate or like the things that you've done more towards the air interface. But if there is one thing that you think is like crown jewel, and I'd like maybe to go for each one of you is to say, what do you really consider? It may be simplicity, maybe some piece of innovation. I don't know, but what would you say?
I think a standard handset, smartphone, or feature phone communicating 2 ways to a satellite on orbit is the holy grail. Just put that simply.
But how
That's
do you,
the innovation.
Okay. Maria, do you have anything to say on your side? Is it what do you think is your and maybe on the business side? I don't know. Yeah.
No, I think for us it's just kind of because at the end of the day, customers don't buy innovation. They buy solutions, don't they? And they buy the right solution for them. So I think, as I say, for us it kind of like boils down to the So first of all, same as Link, for a almost standard IoT device to be communicating to a satellite is innovative in itself, yeah? Because, in the past, we used to have proprietary standards, closed ecosystems, so, I mean, we tend to open source the reference design for the devices. So, a mass market open ecosystem is already innovative in our sector. But as I say, all of these things, at the end of the day, what does that mean for the user? No one buys innovation for the sake of it. So it boils down to a very simple service. It shouldn't cost and it shouldn't feel any different than a ground LoRaWAN service or a standard IoT service. And I think this is really, what again boils down to. Okay. Stefan, anything from the Thales side?
Well, what I can mention is that as a satellite manufacturer, of course, with this opportunity of 5G direct access, we would like to differentiate and innovate on the payload to be flexible enough and reprogrammable so that we can have, let's say, continuous upgrade of the system such a way we can introduce new capabilities on the let's say on the fly with new features coming from the 3GPP. Of course, this is a must if we want to deliver the right level of services and capabilities to our customers. From a system integrator perspective as well, what we want to make sure is to ease this integration between the two worlds. I mean, a seamless integration between the satellite and the ground segment, the space segment and the ground segment. There is a lot of things to do there to ensure that there is the right level of integration between the payload and the base station, meaning the G node, the 5G G node B and the core network. So this is the I would say the two areas where Thales Alenia Space is investing at the time being to make the, let's say, the system successful.
So related to that, maybe because I have a question from the audience, and that's related to what you have just said, right? It's most of the modifications basically looking to integrate space with terrestrial is happening on the physical layer, but they're asking about, the question is about what improvements are being made at the network layer or higher, right? In order to basically integrate these networks together. Would you be able to comment on that, or? And that's open to everybody as well.
Yeah, this is what I said. We need to work together with the usual equipment vendors that will deliver basically the base station system that will be adapted to the NT and to the non-terrestrial network constraints and specification, and make sure that we have the most optimized system so that both can interoperate properly. That's definitively a challenge, and one of the things we are doing on a day-to-day basis with our colleagues and from the, let's say, equipment vendors at the 3GPP level. So that's key for this integration, definitively.
Taigi, go ahead. Yeah, I think you have some. Yeah, go ahead.
Yeah, so one of the ways that we're doing this, like right out of the gate, right, is so for us, it's a big thing. Our LMO is like, this thing cannot change, and the terrestrial network fundamentally cannot change. We want to make it as frictionless as possible with our MNO partners. So what we do in a mobile network, there's a lot of mobility management, right? And usually that's associated with the handsets. Your base stations are static. Ours are not. So there's a mobility management entity piece to our network that we kind of manage, and we keep the terrestrial network somewhat blind to it. They just connect to us through a standard roaming interface. We just look like another roaming partner. So in this way, their network doesn't have to change at all. They just add us to their already long list of roaming partners, and boom, we're in service, right? So I think it's back to what we were talking about a little bit before, right? Is these standards they're actually wonderful. I mean, they've been developed over years and years and years, and they're quite sophisticated. And so there's a lot that you can leverage to make even new stuff like this, right? Like satellite base stations work well with the existing terrestrial infrastructure, how it's made today.
I think there could be an issue of alignment too between the standards, and that I didn't really ask about that, but the satellites are coming in release 16, 17. As I understand, 17 is not yet ready, and companies like Link probably would like to go there already. You have 3 satellites, I understand, right? So
5, yeah.
How's the alignment between the standards and the market strategy, right?
Oh, we don't need release 17 to get into business. Yeah. Our satellites are backward compatible with everything that's in existence today. All 5 billion phones on the planet already. So we don't need any new phones. We don't need any new releases to come out, and Ericsson to make a base station or Qualcomm to make a chip. We're ready to, we're already rolling this out. So once those releases come out, and we'll inevitably take advantage of them as we see fit. And but so they're not needed fundamentally.
One question related to all of this is basically one of the trends that Riyad had mentioned in the presentation, with the cloud players moving into this and providing basically ground station as a service, and closely integrating the satellite networks with the cloud infrastructure. The question is, like, what impact do you see that is having on business, maybe your business and the industry at large? What's your take on that kind of service and basically integrating the cloud closer with the satellites?
I can start actually, because if you like. So again, I think for us, we work actually with with all the cloud providers that are out there, because again, they usually have LoRaWAN solutions, or they have ways of integrating with the LoRaWAN solution. So again, what we do again is compatible with all of them. So for us, it is a good thing, because as I say, they can be a really important channel to market for us. So yeah, I mean, for us, it is a very, very good thing. But again, we work in the unlicensed spectrum world, so I think it is a little bit different, because classical MNOs have not picked up the unlicensed band solutions perhaps as much as NB-IoT or LTE-M. So I think maybe what you said does not apply to us. But what certainly applies is that if the customer want to use AWS or Azure or anything else, then again, our service integrates seamlessly with that, which I think is the most important.
Does anybody think, like in terms of this dynamics between the cloud players and the terrestrial mobile network operators, and then you have the satellite operators, like how's that dynamic shaping up? Do you think they're taking away anything from somebody, or it's basically complementary and largely non-competitive kind of scenario? Or maybe it doesn't apply, I don't know. Yeah.
I think it's generally complementary. I mean, that's my answer.
That's fine. That's fine. So we've got a few more minutes to go. I would like to ask each one of you to basically, maybe if you have a certain ask of the ecosystem, right? What would that ask be? What would you need from the ecosystem itself, basically to provide you or to help you with?
Are you referring to the satellite ecosystem or the?
Well, it can be any ecosystem. Let's say, what would be, let's say, some of the challenges that you see that you would like them to disappear, or maybe some services or solutions. Like what do you think you need in order to basically further grow your business? Maybe spectrum issues. I don't know. Yeah. If there's a single ask. I think the world is perfect. We just need time. We just need time and money to deliver. Maybe it's money that the investment money. All right. No problem. We'll just let that aside. So maybe just to one last thing to touch upon. I mean, personally, I see the need to work together as an ecosystem with the terrestrial players and integrating these networks as being a very big requirement. And I don't know if you share that, and if you think basically those kind of synergies, like for you to succeed, you would need to have better integration and better maybe synergies even with the terrestrial, and whether you are receiving the, let's say, the reception, the proper reception from the terrestrial operators. So maybe that dynamics that needs to change. Any thoughts on that dynamics between the satellite operators and the terrestrial? Because often they didn't really collaborate. They actually collided on spectrum rights and other issues, right? So
if you want, I can start. I think that from, again, the let's say the standard angle, what I see, what is very positive, is that there is a very high level and good collaboration between all those stakeholders. This is really a fantastic time where both can collaborate on the same objectives, and there is a true collaboration between either the satellite network operators or the mobile network operators in this aspect, but also with the, let's say, device manufacturers, the chipset vendors, the equipment vendors. So I think there is a common benefit and goal to proceed and to continue such a collaboration. So I would say that at the time being, again, from a standard perspective, it works pretty well. Of course, there is some disconnect, that's life, and there is some specific strategy pushed by one company or another, but there is I would say a global need and objective to go this way. So This is very positive.
Well said.
All right, and we've got, we basically have reached almost to the top of the hour. So I would like to basically start concluding here. I would like to thank all of you for joining us here. Thank you for your time and insights. I hope that we would continue this discussion. What I would like to do now is to turn it over to Sergi and Monica for the second panel. So thanks again.
Well, thanks again, Frank.
Thanks for having us.
Thanks to all the speakers. I think it's been a wonderful session, actually. It's not only it's been enjoyable, but we have also learned many things, and I'm pretty sure that we could have been talking for hours, since many of the topics that you have exposed, innovation topics or new challenges, are really key for the market that we are addressing. So, I mean, I think that we will need even much more discussions and future workshops about these activities. So thank you all of you. It's been a great panel, and thanks, Frank, for the sharing the session. So now it's time to change. So I change now and I hand over to Monica Roca, that will be managing the second panel. So welcome, Monica. The floor is yours.
Thank you very much. It's been for sure an incredible session, and I'm sure that this one will be very nice too and very interesting. So this within the role of the non-geostationary orbit satellites in the evolved internet, but in particular we'll talk about how can LEO satellite constellations achieve a positive business case. Being LEO, in fact, an orbit that has typically been used for Earth observation satellites where power budgets are a big constraint. But more than 2,500 active satellites now orbit the Earth. One can easily see them with naked eye, and amateur astronomers, of course, see more and more every day. Historically, though, satellite communication have been typically using a geosynchronous or a geo orbit. And on spacecraft, of course, in this geo-orbit. But the non-geostationary or geosynchronous orbit communication constellations, including low Earth orbit and medium Earth orbit too, are taking to the skies these days, and their number could soon soar. If current satellite internet proposals become a reality, about 50,000 active satellites would orbit the Earth closely overhead within 10 years. So we have a list of panelists with us today to discuss all these issues. And the panel, I'll give you 30 seconds if you want to introduce yourself. The first one is Daniel Marco, Director General of Innovation and Digital Economy of the Government of Catalonia. Go ahead, Marco, Dani, and introduce yourself.
Thank you, Monica. I am Daniel Marco. I am from the Government of Catalonia, the Director General of Digital Innovation and Digital Economy at the Vice Presidency of the Government, and also the Ministry of Digital Policy and Territory. I am the person in the government that manages the new space strategy. The Government of Catalonia approved in October 2020 a strategy to boost that we call the new space economy, and we will have some time later on to talk about that. Thank you.
Now we go with Paul Febvre, CTO at Catapult Satellite Applications. Go ahead and introduce yourself.
Thank you, Monica. Yes, I'm Paul Febvre, CTO at Satellite Applications Catapult, and we're a research and technology organisation in the UK, non-profit distributing, and we're working on advanced satellite concepts. At the moment, some of the major projects we're working on, including how do we use these new satellite constellations for position navigation timing, as well as communication, so for hybrid services in the future. My background is in telecoms. I was at British Telecom Research Labs for the first part of my career, working on satellite systems, and then I was at Inmarsat designing the end-to-end communication systems at L-band for digital payloads and digital capabilities. So really fascinated by the opportunities that are being courted by this revolution, really, in LEO satellite communication systems.
No wonder. Thank you, Paul. We go with Jordi Barrera Ars, Vice President of Technology at Open Cosmos.
Great. Hello. Thanks, Monica. So my name is Jordi Barrera. I lead the technical team at Open Cosmos. So Open Cosmos, we provide space missions. So essentially we deploy space infrastructure for anyone wanting to provide certain services from space or getting certain data from space. We manufacture, test the satellites, we get them launched. We providing all these full turnkey space mission provider service to really anyone that desires it. Happy to be here. Thanks.
Thank you, Jordi. Thomas Jensen, Senior Vice President, Satellite Communications of Gatehouse Satcom. Go ahead.
Thank you, Monica. Yeah, Thomas Jensen, Vice President at Gatehouse Satcom. Gatehouse Satcom is a independent provider of waveforms, protocols, products for the Satcom industry. We have been, Gatehouse was incorporated back in 1992, started out working with protocols for radio systems. In 1999, we started working with Inmarsat and has been a partner for the Inmarsat beacon system since then. Our protocols are in approximately half of the beacon terminals active in the market today. Over the years, we have been involved in many Satcom waveform protocols of different types. Besides the beacon one, but we also now see that the satellite is on the panel here. We are also working very close with satellite in 5G narrowband IoT, developing a waveform for the node B that is to be on the satellite.
Okay, thank you, Thomas. And finally, Jaume Sampere, CEO at Sateliot.
Thanks, Monica. As explained by Thomas, okay, what we are doing, it's taking these small equipment, these NB-IoT equipment, commercial modified equipment, and to make them to have full connectivity everywhere. We are deploying a real constellation that will allow the connectivity of these 10 euros equipment everywhere outside the connectivity of the mobile operators. Our business model is to be the coverage extender of all these customers of the MNOs.
Great, thank you. No need to say how great and powerful our panelist list is. So very happy to be here. My name is Monica Roca Parisi, and I'm the president of the Barcelona Chamber of Commerce, but also the CEO of a satellite company. So we'll start with a generic question on this first part, and perhaps we just need to point at different aspects that you can address, and maybe later on we'll go into more detail of these aspects. So the first generic question would be, what are the critical impediments facing LEO satellite constellations and how to mitigate them? And I'd like you to address aspects like the constellation management, regulatory development, debris management, competition, but I'm happy for you to introduce any other subject you like, and later on we'll go into more details on each of these subjects. So perhaps to start with, we can start with Jordi.
Great, thanks. That's a great question. So this is something we have been iterating for a while with our customers, understanding which are the things that they value and understanding which could be the roadblocks, as well as the blocks that we hit on our side. You've mentioned a couple of them that we actually are working quite a lot, and we've done quite a lot of improvements in the last months and years. One is constellation management. So something we are trialing continuously with the satellites we have in orbit is to further automate the operations and go to the extra mile where we can provide actually a lot more flexibility to our customers to essentially do all those payload requests, to do those requests to the satellites that we manage in a way that is almost transparent to us. So essentially we just enable this pipe. We open this copper pipe to them, which they just send the request, and all the infrastructure of Open Cosmos behind the scenes just sends all these requests, manages the satellites, and makes it happen, bringing the data back to our customers, right? So this kind of like no-fuss approach, this sounds very simple to say. Behind the scenes, to make it robust, to provide a commercial service, it is complex. So definitely this is one. The next one that we see is well, these are a common one about cost, about lead times. So essentially something that we embraced since early on was what we call the mass customization. So be able to provide different kind of service to different kind of customers with different requirements, but based on standardized building blocks on our side. So this enables us to shorten the timescales of delivery, reducing the risk, because these are already blocks that we have proven before, or based on proven blocks and improve, and also reduce the costs, right? Because on our side, we essentially manufacture these parts in batches, testing them, and even launching them in batches, which we then can pass these cost savings to our customers.
Great. Okay. You can go ahead and continue but if no one says anything, then I'll call someone else. But otherwise, you can just go ahead and say whatever you want to say around the same question. So we'll make a round. So Daniel, for instance.
Yeah, from a government point of view, what we think and what we want is to really accelerate this kind of constellations and how to accelerate the growth of our companies in Catalonia behind that. And then what we need is to have a critical mass and the value chain of the whole new space sector that are deploying at the same way, because there are more strengths in one part and others. And at the end, what the governments or industries need are end-to-end solutions. And right now, there are specific companies that provide you a unique part of the value chain or a solution, but at the end, when the maturity will overcome, we will have this more global, more also accurate service. And with more quality on the data that we will receive. At the end, we think that the standardization, and maybe later on we are going to talk more about that, it's quite relevant to have also the capability of the connection of the government or the service of the government to different kind of constellations and to share the data from different satellites. Right now, we with two partners here that are Open Cosmos and Satelliot, we have already our first satellite, that nanosatellite, it's Anchaneta, it's IoT 5G satellite. And this is great to start to have one service or many services on the top of that. But what we need is to have more satellites, we have more data and going more faster. And it has been a very short period of time to launch a satellite, but when we will really have our critical services, we'll have in the next 5-10 years that already have this constellation companies like Satelliot, for example. Jaume, maybe you can go ahead.
Yes, thanks, Daniel. We do believe in standardization is the way to mitigate all these impediments. But when we talk about standardization, as you know, we are already working with standard devices, but we are talking about the whole value chain. When we succeed in having a standardization in the ground station service, in the management, it will be the point that all the economies of scale will come up and all these impediments. We have already on the satellite with the CubeSat, which has been a huge evolution on the cost and time needed to build and to launch a satellite. And now we succeed of having the rest of the services that are around Constellation standardized, will mean okay that we could externalize and the cost and the capabilities of the constellations to survive will be much higher.
That's right. Paul, you want to say something?
Yeah, sorry I disappeared for a while. We had an internet connectivity issue and I had to resort to falling back onto satellites. So we're back, so that's all right then.
Do you remember the question?
Yeah, I think I do. I have it here. So
right.
The aspect of impediments with regard to that LEO satellite constellation operators might face, yeah? Fortunately, I didn't hear all of the conversation, but did anyone cover spectrum? Okay, so I think one of the biggest challenges with regard to actually delivering services at scale will be the aspect of access to spectrum and the continuous demand for spectrum, whether they be for terrestrial systems or in future for satellite systems. And I think there's two aspects to this. One is making sure that we can have adequate spectrum reuse and coexistence with other users of the spectrum, whether they be terrestrial systems or other satellites. And the other is the actual regulatory framework itself. And historically, satellites have had to, even when satellite spectrum has been really principally purposed for that, satellites have had to make sure that they can support coexistence when, for instance, terrestrial microwave line of sight links. And the way that's being done historically at the ITU level is to put constraints on the amount of power that can be generated from space on these frequency bands, power, flux density, or power spectral density with regard to unit areas. So flux density is really the model. The challenge is if we want to see satellite constellations actually be able to deliver services to these things in the future, to make it really truly ubiquitous and available to everybody, we need to make sure that we can deliver power flux density that's comparable with a terrestrial network. And at the moment, it's not allowed. And that needs to be addressed if we are going to be part of this future. And it's a regulatory consideration. The spectrum can no longer be used for line of sight microwave links when it's deployed for terrestrial systems. We should now be on the same level playing field with the terrestrial operators, because then the terrestrial operators can actually use this systems to actually deliver services. So that would be the first thing I would put in place.
Okay, that's very interesting. And for sure, we will address this point later on. Yeah.
So maybe I can comment, Monica, also.
Please, go ahead.
You asked a little bit about competition into that. So I would like to maybe draw that a little bit out. So satellite systems have been around for many years, right? And the last past years, we have been talking about old space and new space. Old space being primarily geostationary systems, working from way out in space with a long lifetime, 15 to 20 years, with high production cost and so on. And a few years ago, we started up with new space. A lot of new companies have entered into this market. Many of them started out in a small scale, right? And they are now being commercialized so that you can actually build small satellite systems. So they primarily are placed in LEO, and those small satellites with a shorter lifetime, 5 to 7 years, low production costs. So a completely different setup and economy. So if you would have asked me about this maybe a year ago, we would all probably have asked that there would be competition between old space and new space, and we would be discussing how new space would, outcompete the old guys. That's probably not going to happen, and we see some of these things happen right now. Some of the old space systems, they start with small satellite systems on their own. Some buy systems and so forth. So in the future, I think what we will see is we'll see a completely new space economy, where you will see systems that will have satellites in all orbits, LEO, MEO, and GEO. So the competition picture, or or the competition map, will change completely over the coming years. And all of this you have to combine with what the other guys here have been speaking about, all the standardization that is going on. That is also a game changer into the satellite world. It's a game changer in the way, if we look at the old space, if we call it that, their system have been proprietary. If they had a protocol used in their system, you could not take that protocol and use it in another system. That means that you would actually be locked in to that system, and it would have high cost to move to another operator, satellite operator. The standardizations are going to change this. And we saw it from the beginning of the development of the mobile phones, right? You could not take your mobile phone. Back then it was a big chunk of a mobile phone, but you could not take that from Europe to the US or from Europe to Asia and have connectivity. This was solved with all the standardization. And the perspective that we are looking into now with what is going on in 5G is actually that you can use your device on any satellite system. So you will go, as we do with our mobile phone, and choose the operator that serves you the best bandwidth, the best pricing. So I think that will change the competition map and picture dramatically in the coming years.
Right. Yeah. In fact, there's a lot of things that come to my mind while through your speeches while you're speaking, and in terms of this competition between the old space and new space, I tend to normally make a comparison with the computation capacity, and we need supercomputers. Definitely, we need supercomputers, but we also need laptops, and we also need the smartwatches. So in a way, in the space, it's going to be the same. It will not be competing really the classic space, as I call it, rather than all, because I'm still on the classic and I don't want to call it all. And the new space, definitely. And it will be a combination of both that will coexist, definitely. And the globalization, as we call it in many other aspects, it will be a globalization of satellite, which is something that a satellite is by definition global, right? But still we will, and this coexistence and interconnectivity among all of them will definitely exist. I agree with that. Right. Maybe before we go to the regulations, because that's going to definitely take an important part of this discussion. Maybe I would like to address a question first, which is this: what is the impact of both new technology and business model innovation on the LEO satellite business case? You're welcome to address again points such as what kind of new companies are entering the markets due to the expansion of this innovation of LEO satellites, or what new opportunities have brought the IoT and the 5G markets. And then we'll go into regulations. And perhaps now we can start with Paul or anyone else.
I don't mind having a first start. I think what's really fascinating, if you look at the advancing of the technology over the last few years, is how you can do so much more in software these days than you could. So I think the aspect of being able to reconfigure the hardware affects not only the devices that we would deploy into the field, just essentially doing upgrades and the like, but also what the software in the satellites might be able to support. And I think that's really one of the most fascinating areas, and partly it's being driven by cost reduction requirements in terrestrial systems, like the virtualization fabric, the ability to have multiple personas on device, essentially multiple applications, multiple security enclaves in a single device, so you can use it for different purposes. If I could reflect on the aspects of the base station technologies that are available now for 5G and beyond, and what it means from the perspective of us able to build very flexible architectures in space, but also in the ground segment. And coming back to Thomas's point, I think the aspect here of standardization is important, but I think the potential flexibility with regard to the configuration of the hardware to support multiple standards is also an enabler. And one of the reasons I think this is going to be very important, if we think about new markets, what are the new markets that perhaps we could address, address? And I think one of the most significant new markets relates to vehicle connectivity, automotive connectivity, connectivity for everyone, everywhere, where it's really not possible from an economic perspective to actually provide services on a terrestrial network to cover everywhere. But yet there's a requirement for those vehicles and the people in the vehicles to have connectivity. And when you think about that, the implication of that is that the infrastructure that goes into the vehicle is not chosen by the person, it's elected by the automotive OEM. But that's fine. Perhaps you'll get that as part of your service pack when you actually get the vehicle, so it's a business model consideration. But what happens when the car goes into the second-hand market? How do you then provide those services? And will it be from the same satellite operator and the same terrestrial provider? Or will you want to be able to switch and to have an open market with regard to procuring your services moving forwards? So I think the aspect of technology and be able to reconfigure it to actually take advantage of new infrastructure that might be deployed in space and in the terrestrial domain, and to be able to do it as a download, a software upload on your vehicle, for instance, brings really interesting and innovative constructs to not only the customers, new business models can be enabled by that. And it's really that software technology taken to the actual, make sure that the consumers can actually take advantage of it. I'll start with that.
I think Jordi has started his first intervention with flexibility to our customers, right, Jordi? So maybe you want to say something now about this?
Indeed, I totally support Paul's point. So this is something that has been continuously on our designs, right, on our satellites. So we see both these on the payloads. So our customers are currently iterating the software on our payloads already on a week or monthly cases. We already see these. Also on our side, we have been improving the software and enhancing the level of service we provide through essentially improving both the ground segment, but also the software on all the subsystems of the satellite. So this improvement on software is across on power systems, on communications, on payloads, on the antennas on ground, absolutely everywhere. And we have seen how we, from the launch point to actually 6 months down the line or 8 months down the line, that satellite is a lot more capable already based on what we have been able to test and iterate on. So definitely, yeah, this is a massive thing. Yeah.
Well, thanks. Someone want to intervene? Jaume, perhaps, because we're talking about...
Thanks, Monica.
Yeah.
I really believe, okay, that what's more interesting about all this, it's the new business model and the new market it's appearing on all around the world. Okay, we are most of the people that we talk with, okay, they are thinking about extrapolating that the connectivity that we have today, okay, will be much cheaper and everywhere. And the reality is that it changed everything, okay? There is a lot of new applications that we are already seeing on the market when we talk about with other resellers, with final customers that we have never imagined that could be a reality. Of course, some of them, it's about the connected car, which seems obvious today, okay, that it will be a generalization of in all the cars, okay, in second-hand new cars, doesn't matter, all will be connected. But apart from that, there is a huge bunch of new services that today does not exist, and that will be a reality. We are working with people in US, for example, that it's deploying a TAC, okay? That it's a TAC that has NB IoT connectivity inside, okay? With people that it's on the monitoring of sun temperature on the desert, with people that it's looking at environmental resources. There is everywhere new services that are appearing, and I'm sure that all the calculations that we are making, we all, okay, not just we all are making about the new markets that are opening, it will be dismissed by a reality that will surpass, like every time has happened, okay? It's happened when the mobile appeared, okay? Nobody understood why we need internet everywhere, okay? It seems something that it was, but why do you have to be connected? And today, it's completely necessary wherever you are, okay? And 5G IoT will mean the massive, I love this word, I love that, massive IoT everywhere. And this is what will change the world we know.
I can add, Monica?
Sure.
Thanks. Looking forward for the analogy that you are doing, Monica, about the high computing services and laptops or mobiles. Here in LEO, all the space and new space also have a different that LEO or the new space creates really an open platform because it provides affordable technology, more cheaper technology, and a unique space, a unique way where a startup, an entrepreneur can really connect the needs of the users to the technology that providers like Satellite are doing, and here the use cases are open to many different areas. For example, us in the rural areas, we are right now identifying what we can do if we have connectivity everywhere, because we already have very good connectivity, but it's the connectivity where the people is living or where the companies are working, not really everywhere. and right now open different use cases to manage the territory. And it will be also very new opportunities connecting the IoT connectivity, for example, with Earth observation, with other kinds of satellites, because we will have the data from really the Earth to sense what we are doing, and also from the space. And innovation is at the core of that. Innovation, we have these different possibilities, and really with artificial intelligence, with different technologies combined, we can provide these new solutions. And I am sure that in the next year, a lot of different companies will appear, and some of them will be success, and some of others not. It depends at the end of the market. But we have started within the government of Catalonia doing some workshops with different departments to what you can do, what we can do with the nano satellites we are launching, and a lot of ideas are appearing. And what we need is companies that are going to provide these kind of solutions.
Maybe I can comment a little bit here also, Monica.
Sure,
maybe a little on the side of your question, but I think the standardization that all of this also evolves around is that it will be much more accessible to the end user in all the scenarios, right? So if I have to go out and buy a satellite terminal and a subscription today, I would probably have to sit down with Google and have some help for an hour or two to find a terminal and a subscription and where to buy it and all of that. In the future, you will be able to buy your satellite connectivity with your mobile network operator. That means that I know my local network here, so I will just buy my device there and my subscription. It will be very easy. That means that it will be accessible more widely, a lot more widely, right? So and to what Paul mentioned as well here, so it connectivity will come in all ways that we are not using it today. So in the maritime, where we have self-sailing ships, self-driving cars on land, and UAVs in the future as well. All of these places you will see connectivity come in and play a lot bigger role than it has today. Today the technologies are being developed, and you see the beginning of self-driving cars but this will be much more than normal in the future, right? So connectivity and the SATCOM part of that, so that you don't lose your connectivity to your car when you drive outside of terrestrial networks, plays a huge role. And on the SDR side, when we are talking software-defined radio, so it's much easier to make an update in software than it is to update millions of devices of hardware, right? So you can keep as long as your software-defined radio is not outdated, you can update your functionality and your service. So that technology also plays a huge role into what we will see in the future.
In fact, I think both Thomas and Danny, you've both addressed something indirectly, perhaps, but that I would say coverage. In fact, coverage is what you gain. One of the things that you gain with all these large networks of satellites, let's say, flying around the world, you get a lot of coverage that you wouldn't have otherwise. And that's why I have also sometimes make the similarity that I made before, because when you have many more, and they can fly all over the places, and that reduces the distance, let's say, between the ground tracks, and that's how you increase this coverage, and that's how you can get this democratization in a way, both from the user point of view and from the developers of the technology point of view. I think we democratize both, in fact, the fact that everything is cheaper and shorter development time, also brings a lot of new players, but definitely from the user point of view, there is a lot more than, there's this coverage that will be used for many applications indeed. Right, okay. So maybe it's time to start talking about standardization and business, and how to achieve lower user terminal costs. And will the standardization generate quick revenues? and how important it is to have quick revenues, in fact. So who wants to start with this standardization and business question?
I will do if you allow me. Okay,
sure.
Because it's on the base of our business case. Okay, we just work with standard devices, as it was explained on the panel before. Release 17, that is the new release of the NB-IO standard that we have been working together with the whole industry for the last 2 years. We will allow that the standard and modified devices connects directly with a LEO constellation like the one that Terrestrial, jointly with our partners here, are deploying. This means, that, and we arrived to an extreme, that we are already signing pre-commercial agreements with mobile operators that will have all the customers enabled by default the roaming with our constellation. This means, that what Thomas was saying about that everybody would be much easier to have satellite connectivity. Most of our customers will never know if they are connected with a satellite or with a base station. The roaming will be so seamless, and will be activated by default that they will, and some of them, they will use it very few, most of us that we live in cities where there is mobile coverage, but just this 2% of the time, when they lose connectivity and they will roam automatically with a satellite constellation. And of course, if you ask them, have you been connected to a satellite? They will ask, no, I am exactly the same device and connection that I have always had, but they will have full coverage on this moment.
Right. Yes, indeed. Thomas, you want to address this?
Yes. So I think the standardization is all about, making, as Xiaomi says, transition between terrestrial networks and non-terrestrial networks seamlessly. We will not know that in the future. So that is also going to be a game changer, right? I think so. I think one other aspect of this is, for example, that how many satellite-enabled IoT M2M solutions are there today? Maybe 5 million, right? I think systems like Iridium have around maybe a little more than a million terminals, and Inmarsat in their various segments also a little more than a million terminals, right? So when we go into standardization, and the perspective here is that it will be so standard that the chip manufacturers will start producing chips and dual chipsets that will work both on the terrestrial networks and the non-terrestrial networks, then things will start to change, right? So when you buy for example, a narrowband IoT device, you will not have to choose a terrestrial, non-terrestrial. The device will be born to be able to work on both types of networks. So yeah, that's the future.
Just to add a number of these, there are already 2 billion NB-IoT devices in the world against the 1 million of Iridium devices, which is amazing.
Yeah, so I think predictions into the future, you can find many hockey sticks in that. It's typically like that when you try to predict the future, but the potential is that you will probably have 500 billion enabled narrowband IoT devices that can go over satellite, right? So, yeah.
Anyone else wants to add something on this?
I think, Monica, when you ask about how do you lower the cost of terminals, it is all about scale at the end of the day. Mm-hmm. And standardization is a route towards achieving that in terms of actually getting critical mass. It's not the only way, clearly. An organization can choose to just do everything vertical, put the infrastructure in and actually make things available. But there's two aspects here, I think, with regard to not only the scale that I want to just complement. The first is to make sure that the manufacturing of the devices itself and the investment associated with producing the devices is proportionate to the expected volume. And the only way to hit really low price is to automate. So there's the aspect of increasingly the automation in the manufacturing that's critical, and that today is much more accessible if you like, than it was historically, because you can leverage techniques and for automating your manufacturing process that were previously unavailable, and you have to do it all yourself. The second is, from a services perspective, the only way to hit not only the product price point, but the services price point is if the infrastructure in space has the capacity to support the expected volume and beyond. And that is making sure that the technology that we deploy is essentially going to position the satellite services competitive when they're compared with terrestrial systems. So I think manufacturing of the products at scale and infrastructure in space that is essentially proportionate to the expectation with regard to the user demand is critical.
Right, I fully agree. I was going to say, through standardization is how CubeSats became famous, right? So definitely.
Yeah, it can add. I think that right now in the technology area, there are three main pillars that always needs to be done. That it's seamless, simplicity, and also to doing the things that have long-term decisions, because you need to have as an user, from myself, if we are going to make a deployment, we need to use devices that are with interoperable standards and not be close to one or another operator. And at the end, the only way to do that is really to have standards and operating standards if are possible. And this will be also the way where small companies can deploy their own solutions, because maybe a big company can deploy their appropriate the standards, but if we want to put really innovation on that, we need to use open standards to provide them the platforms to develop their services.
Right. Finally, because we're running out of time, it's funny how time flies when things are so interesting. So there is one point that is somehow related, but I think maybe we deserve some mentioning, and is the regulations. But I'm going to allow myself to link it to a final point that I'd like you to make before the summary, let's say, which is the impact on the ecological, let's say, and climate implications of this exponential increase of a space activity. So maybe we can link them both. I mean, how regulation will help, but then also the impact on how all these amount of satellites impact on the Earth itself. Go ahead and link them both as you wish. Or address one or the other, no problem.
Okay, well, I think there's really fascinating, and when you met regulatory and ground segment and this kind of thing as well in your opening, Monica, I think the aspect here about how do we make sure that the services are accessible everywhere is going to be critical to make sure that they have the aspect of societal benefit. That might require ground segments in territory to make sure that it's localized the services and that sort of thing. So there is aspects of that, but there's also a cost implication of the ground segment when you do that. And having the ability to create networks of satellites in space, as Thomas was mentioning, where you leverage the existing infrastructure to do things in a cost-effective way and a sustainable way is important. I think final point on the aspect of sustainability, I think that this is really fascinating to consider the economic aspects, not the commercial aspects. So once you provide connectivity for communities, those communities can actually do things in a much more effective and efficient way than they could if they didn't have connectivity. You waste less energy. And if you were to look at satellite and not think about just the carbon footprint of putting it into orbit, but the carbon saving that you get from actually using the services that influences every part of society, what you find is at least a 10 to 1, if not 100 to 1 benefit. So satellites are carbon negative, not carbon positive.
That very much depends on what you do when you launch it. It's the launch that makes a huge difference.
I don't think so. I'm sorry, I'm going to contradict you there. I think the actual cost, the carbon footprint associated with launch manufacture is negligible, almost negligible compared.
The launch itself?
Negligible, nothing, zero, close to zero. And when you actually look at the total cost, I'm serious about this, you actually look at the aspect of, let's take an example. I'm going to use GNSS as an example, right?
Right.
4 satellites in a MEO orbit. a number of launches to get it in there. Each launch is equivalent to a few transatlantic flights. And if you put those satellites into say, well, what does it save in terms of the transport infrastructure, the carbon footprint for transport infrastructure on a global basis, you are talking of megatons, if not gigatons of carbon. And the actual launch and manufacturing of the satellite infrastructure in space is negligible compared with the benefit.
I'm happy for you to say that. Anyone else?
There's definitely things that Paul has mentioned that we actually see on applications. We are working on a few missions for Earth observation ourselves, but we see the things that our customers are looking at for change detection on Earth to actually essentially support all this climate emergency. Definitely these things are the things that we need. So I totally echo what Paul is saying, like the benefits that we're getting from space probably outweighed by a lot, the drawbacks of actually the carbon footprint of launching those assets. There's another point I wanted to mention, which directly touches on how we manage our constellations and the constellation of our customers, which is essentially being a responsible operator, right? Open Cosmos, we are operator of satellites on behalf of our customers. We maintain those assets there, but also we want to take care of obviously the environment, because at the end it's really where we thrive ourselves, right? It's our home. This is as an operator, there are essentially certain rules that you need to obey. But at Open Cosmos, we go a step forward, making sure that our satellites are deorbited even well below what is legally required, right? So we actually don't see the need to keep these satellites up there because our customers don't need it, and hence we don't do so. So if everyone behaves this way, it can be sustainable and can be done responsibly. Now, unfortunately, events like what we have seen in the last days, etc., do not help. And for this, we need a push for everyone. Really, everyone has a role in here, operators, governments, absolutely everyone, to keep this place essentially sustainable for the future, definitely.
I agree on that, Jordi, because right now our message to the society is that space and new space is helping us to combat the climate change and to be more environmental society. But always arrive some questions about the garbage that we are looking and the clean space awareness on that, and the technology can help us. We need to start with this green technology, green new space, and green from the design. And if we are green from the design in the development of the missions, there is technology that can help us to recover the nanosatellites and use that to be more sustainable. But because I think that right now the ecosystem and the companies, the sector, it's very aware of that, because all the users are aware, and green needs to be in the design of the vision.
Fully support that, and I think that satellite bring incredibly useful information without which we wouldn't be able to take the right decisions. So that's very, very important to have this, but it's very good that it's well argued and explained, because these days we cannot do anything that is not green, let's say. So yeah, anyone else? I think we're very, very close. And in fact, we'll probably pass already 2 minutes. So we need to close this extremely interesting session. If anyone wants to say something else to close, knowing that it's going to be the last intervention.
No, just I fully agree with what Paul says, okay, and just want to put a number on the table. 70% of the water today is expended on agriculture. The use of massive IoT in agriculture will mean a reduction of 40 to 50% of the water needs, which is a huge impact of the technology that I love what Paul says, okay, that it's negligible.
I was going to use that as an example, right? So I think that's really interesting, but there's another domain which is also really important. As we move from point-based power stations to generate electricity into the future, where we're talking about renewable energy systems, they are wide area scavenging systems. They operate over very large areas, and the critical requirements to make sure that those are operating efficiently and effectively for the future is to actually have them connected digitally. And the only way to do that effectively is satellites. So satellites will be part of this future for power generation on a sustainable way in the planet, as well as the farming.
Anyone else to close? No? Well, long live space. I think that's what we can say, because it's bringing not only information, but it's also green. So I think after the COP26, being able to say this, I think it's very important to send this message. And I think we also can say that we need regulation that's clear, and we definitely need the standardization to make everything cheaper and more usable. I think with that, thank you very much to all of you. It's been incredible. Thank you also the organization, I2CAT. You probably say it in English, right? And with that, I think I give the word to Sergi to close this interesting session. Thank you very much, all of you.
Okay, thank you, Monica, and thank you, all the speakers. So, well, here we have reached the end. We just want to thank you, all of you. I mean, it's been a very two interesting panels. We have not, as I said before, we have not only been listening to new ideas, we have learned a lot of new challenges that we have ahead. So we are very happy about this. So just before closing and giving the hand to Riyadh, I just want to inform you that we are thinking also next year maybe to have the chance to have the first physical virtual event of this series of workshops that we are organizing, because we think that it's also important to put all these people together, because there's lots of synergies, lots of opportunities, business opportunities actually, and we can also see not only how we can impact the business side, but how we can impact also the administration side. So that's all from my side. Thank you very much. We'll make a resume, and I hand over now to Riyadh that will make just some comments. Riyadh.
Thank you, Sergi. Yeah, I mean, a couple of hours filled up with a lot of knowledge and very interesting. So now, without adding too much, just wanted to thank all the panelists, thank the moderators, thank the organizers, and specifically thank the audience. Yeah, so any follow-up question or any request post this, feel free to reach out, and we'll be happy to follow up. So I would like to thank you all, and hopefully to the fourth workshop sometime in the future. Bye-bye.
Thank you very much. Bye.
Thank you. Bye-bye.
Bye. Thank you.
Thank you very much. Hope to see you soon.